OBS started up this time. And we've got ourselves a preview window. Awesome. All right, so we've got everything set up here. Let's go verify, get everything else set up. Good morning, Stacking. Yep, first day unemployed, fun employed, and already slacking. I let myself sleep in a little bit this morning. Let's see, where are we currently at here? Oh, right, we're at this special spot in here. And let's go ahead and open up our text too. It is, and it was interesting. We had a bunch of parties on Friday because another coworker of mine was leaving at the same time. So we ended up, like, this weekend was fairly interesting and hectic. But things should calm down now this week. All right, this project fine, learning Rust. And there we go. Let's see. All right, let's hop to it then. First, we create a new trait named fnbox. This trait has the one method callbox, which is similar to the call methods on the other fn traits, except that it takes self, box, dine self. Take ownership of self and move the value out of the box t. Dan did bring up a good pointer Friday. Since 2018 has been delayed, you should really switch back to the second edition book. Yeah, that's a really good idea. All right, so we're in chapter 20. We're in that section. Oh, it won't let me. If I come here, second edition, and we want to go to chapter 20. Right here. On, find. Oh, that section is not there. Interesting. It'll avoid all the headaches. Yeah, it will. Okay, so do we need, so improving thread pull with the thread pull. So we did that. Thread spawn, creating a similar interface for a finite number of threads. We want our thread pull to work in a similar, familiar way. We use thread pull new to create a new. Building thread pull struct using compiler driven development. We did that. Next section. Validating the number of threads in new. I think we did that, so it's greater than 0. Creating space to store the threads. I think we do that, right? We have public function spawn. Have that, don't we? Okay, so public function spawn, this is, oh, here, spawn. So we have thread spawn, we don't have worker. Spawn functions, spawn was them showing you how what's its name worked. Oh, okay. It's not really doing it. Oh, let's look at the thread spawn signature. Okay, got it. Then we do this. So thread pool new, create some threads. A worker struct responsible for sending code from the thread pool to a thread. Wait, is that where we are? Nope. I think we were doing this. We left this. Modifying thread pool. Okay, so we got worker, the join handler. Like, were we about to do the join handler, or thread join handle, struct worker, thread join handle, do that. Implement worker. Oh, I don't think we have exactly this. So public in thread pool, we have public function new. Oh, interesting. We're not making that public. Thread pool assert size is greater than 0. Oh wait, this is not worker. This is thread pool. Thread pool. So new. Yeah, this is public. That meet workers equals effect with capacity size. That send and receiver. Oh, they don't have that here. For ID and 0 size, workers.push. Okay. Sending request. So here's our send and receiver. So we've got that. Implement thread pool. Okay. Let's try passing and receiving end of the channel into each worker as the thread pool creates the channel. So that's workers push. Oh, we had to do like the box stuff. Mutex and arc. So we did that. So that was about adding a new trait. Implementing the execute method. Adding a new trait, FN box. That's it. I don't know why. This feels like it's the same search, but for some reason it wasn't grabbing it. But this is where we're at. Okay. And we're in the second edition now, so perfect. First, we create a new trait named fnbox. This trait has the one method callbox, which is similar to the call methods on the other fn traits, except that it takes self box self to take ownership of self and move the value out of box t. Next, we implement the fnbox trait for any type f that implements the fnonce trait. Effectively, this means that any fnonce closures can use our callbox method. The implementation of callbox uses this, so dereferencing self to get the actual call closure and then executing it to move the closure out of the box t and call the closure. We now need our job type alias to be a box of anything that implements our new trait fnbox. This will allow us to use callbox in worker when we get a job value instead of invoking the closure directly. Implementing the fnbox trait for any fnonce closure means we don't have to change anything about the actual values we're sending down the channel. Now, Rust is able to recognize that what we want to do is fine. This trick is very sneaky and complicated. Don't worry if it doesn't make perfect sense. Someday, it will be completely unnecessary. With the implementation of this trick, our thread pool is in a working state. Give it a cargo run and make some requests. All right, so a good time to like actually test to see if this is working. Cargo run. All right, thread main panicked at index out of bounds. The length is 0, but the index is 0. The length is 0, but the index is 0. All right, so let's run this with a Rust backtrace. So go run. Do I do it here? Oh no, I probably just do export Rust trace 1 cargo run. All right, so thread main panics. Let's see if we can find out where this is. So this is all none of my stuff. Quit panicking, continue panic, panic format, panic bounds checks, slice index. Okay, source librs line 32, thread pool new. So librs line 32 right here, new. So okay, so workers ID, worker new ID, arc clone, and then we hand it the reference to the receiver. So we're getting the receiver, so that should be fine. The ID, and what exactly is this error message again? Thread main panicked at index out of bounds. The length is 0, but the index is 0. Okay, so for ID in 0 to total threads. So is it, do we not have any total threads? Or did it not create them properly? Mute workers equals vec with capacity. Let's see if we can find thread pools implementation here. Okay, so thread pool, that's still, we want the full thread pool. All right. Public function new, size usize, thread pool, assert size is greater than 0. So that sender and receiver equals MPSC channel. So if we move that up, that's the same so far. Let receiver equals arc new mutex new receiver. So let receiver equals arc new mutex new receiver. And we do this up here. Okay. Let mute workers equals vec with capacity size. Threads, okay, so that's our size. Then for ID in 0 to size, 0 to the total threads, workers dot push. Okay, so stacking, looks like you are correct. It is very unhappy with this line. This workers ID is not what we wanted to do. I was kind of hoping that it would, because other languages you could just like create an empty, initialize an empty vector like this, and then just like go ahead and assign each index. But it looks like instead of this, we're gonna have to do workers.push worker new the ID, and this one is going to be arc clone, and then we're going to hand it a reference to the receiver. All right, let's see if this works. It's too bad that it also didn't give me any kind of error there. All right, so cargo run. And that was it. So stacking, you are correct. We couldn't do that. All right, so let's go ahead and hit this. Go to localhost 2000. Hello from rest server, and then if I go to like slash sleep, and also localhost :1000, it's still running even though this was having trouble here. So perfect. Our web server is running. All right, we have to go back to Okay, so here we are, and it's running. We are getting those fields never used, but that's okay. Success, we now have a thread pool that executes connections asynchronously. There are never more than 4 threads created, so our system won't get overloaded if the server receives a lot of requests. If we make a request to sleep, the server will be able to serve other requests by having another thread run them. After learning about the while-let loop in Chapter 18, you might be wondering why we didn't write the worker thread code as shown in listing 2022. So let's see how this is. We have our function new in worker, okay. The thread equals thread spawn move while let, okay. So it's sort of like an if let, but a while let. This code compiles and runs, but doesn't result in the desired threading behavior. A slow request will still cause other requests to wait to be processed. The reason is somewhat subtle. The mutex struct has no public unlock method because the ownership of the lock is based on the lifetime of the mutex guard within the lock result mutex guard t that the lock method returns. At compile time, the borrow checker can then enforce the rule that a resource guarded by a mutex cannot be accessed unless we hold the lock. But this implementation can also result in a lock being held longer than intended if we don't think carefully about the lifetime of the mutex guard. Because the values in the while expression remain in scope for the duration of the block, the lock remains held for the duration of the call to job.callBox, meaning other workers cannot receive jobs. So interesting, because it doesn't go out of scope, it doesn't release it, doesn't unlock it, therefore nothing else can lock it. By using loop, deadlocks are the worst, yeah. By using loop instead and acquiring the lock and a job within a block rather than outside it, the mutex guard returned from the lock method is dropped as soon as the let job statement ends. This ensures that the lock is held during the call to recv, but it is released before the call to job.callBox, allowing multiple requests to be serviced concurrently. And that is adding in some threads. So I'm gonna go ahead and add this fix in here. So it's the only thing, like we fixed. I don't think we did anything besides this. It's 3 changes. Oh right, yeah. So stage changes. What did we do? We fixed bug when trying to insert worker threads to vector. Okay. So that on to the next section. Graceful, shutdown, and cleanup. The code in listing 2021 is responding to requests asynchronously through the use of a thread pool, as we intended. We get some warnings about workers, ID, and thread fields that we're not using it in a direct way that reminds us that we're not cleaning up anything. When we use the less elegant Control-C method to halt the main thread, all the other threads are stopped immediately as well, even if they're in the middle of serving a request. So what that means is, okay, so if we have sorry we're tired, if I hit this and I come back to here and just do Control-C, it just instantaneously destroys all of the threads. Now we'll implement the drop trait to call join on each of the threads in a pool so they can finish the request they're working on before closing. Then we'll implement a way to tell the threads they should stop accepting new requests and shut down. To see this code in action, we'll modify our server to accept only 2 requests before gracefully shutting down its thread pool. Implementing the drop trait on thread pool. Let's start with implementing drop on our thread pool. When the pool is dropped, our threads should all join to make sure they finish their work. Listing 2023 shows a first attempt at a drop implementation. This code won't quite work yet, but we can implement this too. So implement drop for thread pool. We create a function drop. It's an internal function. We take in a reference to a mutable self for worker in the reference to mutable self.workers. We're going to print that line. Okay, we're shutting down a worker blah, and then the worker ID, worker thread join, unwrap. So all we're going to do is like loop through all of them and attempt to do that. Of course, I mean, they say it won't work. So this implement drop for thread pool. Let's go ahead and find that and add it in. So implement thread pool. Here we go. Implement drop. Is it drop with a capital D? Drop for thread pool. And this is function capital drop. There's lowercase drop here. So drop, this is going to take a reference to a mutable self. Is there anything else we need? No. We're not going to return anything. And the only thing we really want to do here is just loop through all the workers in here. So self.workers. Because in thread pool, struct thread pool, we have workers right here. So for worker in, I guess they say it's a mutable self. Is it space there? Yeah, mutable self dot workers. Worker dot oh, I guess like first we want to print the line and saying, hey, we're shutting down this worker, worker.thread.join. Okay, so first do our print line, halting, or halting thread, and then it's going to be worker.id. So workers, self the workers, I think that should be it. Yeah, worker.id. And then in here we're going to do, okay, so worker.thread dot, is it halt? No, join. The join handle or just join? Just join. And then we'll unwrap it to make sure we'll just like quit immediately if it fails that. Okay. Cannot move out of borrowed content. Reference to mute worker. Okay. It thinks I should do that. Mute self workers. Oh, right. It won't work yet. First, we loop through each of the thread pool workers. We use mutable reference for this because self is a mutable reference. And we also need to be able to mutate worker. For each worker, we print a message saying that this particular worker is shutting down. And then we call join on that worker's thread. If the call to join fails, we use unwrap to make Rust panic and go into an ungraceful shutdown. Here's the error we get when we compile this code. So we cannot move out of borrowed content. The error tells us we can't call join because we only have a mutable borrow of each worker, and join takes ownership of its argument. To solve this issue, we need to move the thread out of the worker instance that owns the thread so join can consume the thread. We did this in listing 1715, if worker holds an option thread join handle. Instead, we can call the take method on the option to move the value out of the sum variant and leave a none variant in its place. In other words, a worker that is running will have a sum variant in thread. And when we want to clean up a worker, we'll replace sum with none so the worker doesn't have a thread to run. So we know we want to update the definition of from worker like this. Okay, so struct worker. So now it's going to be a thread of an option thread join handle. Because I think it's just thread join handle right now, right? Struct worker. Yeah, so thread join handle. So we need this to be an option. Oh, it's not parentheses. It is those things. Yeah, you definitely we got that. All right, so we've got some errors now here. First of all, expected enum standard option found struct standard thread join handle. So thread, this now needs to be an option. You're pretty quick today. I mean, I guess I got a little bit more sleep. that might help. Oh no, this is a type, so it's not an option. I want a sum. So that should handle that. Then in here, why are you? That's a weird color to me. I mean, it feels like a weird color to me. Okay, so worker thread join, no method name join found for type standard option in the current scope. Okay, right, because it's an option. So worker.thread, and I think they were saying dot take. Attempted to take value of method take on type standard option. Attempted to take value of method take on type standard option standard thread join handle. Maybe yeah. That. And then join. No method name join found for type standard option standard thread join handle. So if I do take, then it's more than just a join I have to do. I have to then like get the actual value out of it. So let's see how they're going to handle that. Now let's lean on the compiler to find other places that need to change. Checking this code, we get 2 errors. So we've got that one and we've got this one. So we already fixed this one ourselves. Let's address the second error, which points to the code at the end of the worker new. We need to wrap the thread value in sum when we create a new worker. Make the following changes to fix this error. Some thread, yeah. The first error is in our drop implementation. We mentioned earlier that we intend to call take on the option value to move thread out of worker. The following changes will do so. So if let, so that's what we need to do. We need to do an if let sum, like the thread, equals the worker.thread.take, and then we can do the thread.join. So that's what we need to do. So instead of this line, we're going to do a if let sum thread. It's not going to be equal to thread. It's going to be equal to worker.thread.take, like that. So then on this thread, we're going to be able to now join and unwrap. All right, see if that makes it happy. All right, it seemed to. As discussed in chapter 17, the take method on option takes the sum variant out and leaves none in its place. We're using if let to destructure the sum and get the thread. Then we can call join on the thread. If a worker's thread is already none, we know that worker has already had its thread cleaned up, so nothing happens in that case. Signaling to the threads to stop listening for jobs. With all the changes we made, our code compiles without any warning. But the bad news is this code doesn't function the way we want it to yet. The key is the logic and the closures run by the threads the worker instances. At the moment we call join, worker instance at the moment we call join. But that won't shut down the threads because they loop forever looking for jobs. If we try to drop our thread pool with our current implementation of drop, the main thread will block forever, waiting for the first thread to finish. To fix this problem, we'll modify the threads so they listen for either a job to run or a signal that they should stop listening and exit the infinite loop. Instead of job instances, our channel will send one of these two enum variants. So enum message, a new job, or terminate. So where do we want to put this? Probably just up here and just have it be a type. So we have a trait, we have an implement, then we can have an enum. What are we calling this? Just message. And so we're going to have a new job, which is a, I guess a tuple type, and a terminate. So job, and I guess it's just the job. Oh, right, type job. And then also we have terminate. All right, so given that, now where would we want to put this? So before I look, when we hand it, where do we get this message? So we have sender and receiver. We find the actual closure. So there's the execute here, closure. That job equals box new. We hand it the closure, self, sender send job, unwrap. This is the job. So that job equals box new closure. So I think what we want to do is implement a new enum, put the job into new job. So I wonder if I can do this. We'll say let job equals, it's going to be message. New job, and we're going to pass it in the closure. Mismatch types, expected struct, standard boxed box, found parameter, found type parameter. Right, okay, so because we pass this in self sender job, is that in main? Where's our forever loop? Bind address, thread pull for stream and listener, wrap unwrap, thread pull. No, it's not in main. It is library s. Okay, so we have callbacks here, fn once. Well, this is calling it. Function callbacks, self callbacks, it's just running that. Where's the actual closure? Where did I put that? Here it is. Okay, so implement worker, thread, some thread, spawn, move. We have this implement infinite thread, let job equals receiver dot lock. Okay, so this is a problem because this is a, what did we throw in here? We put in this message new job. So I almost want to match I guess it's going to be some thread spawn. So that job equals receiver, lock unwrap v, job callbox. So match on job maybe? If it's a message new job, job, then we want to call this code right here. Okay, if it's not, so else, it's the only other possibility is it's, well, I could just use the message terminate. Okay, so if it's message terminate, we want to break out of here. So can I just call break? I guess I can just call break here. And that should terminate this loop. All right, so let's see if that's what they did. This message enum will either be a new job variant that holds the job the thread should run, or it will be a terminate variant that will cause the thread to exit its loop and stop. We need to adjust the channel to use values of type message rather than type job, as shown in listing 2024. So in here, in thread pool, this hasn't changed. Implement thread pool, execute. This looks the same as what they had before. Job equals box new f. Self.sender.send message new job. Okay, so implement thread pool, public function execute. That this is sender.send job, message new job closure. I think I got that. Still upset. Yeah, so this is all the same because job equals new job job. Oh, there's no box. That job equals box new closure. Okay, so I need this to be the message new job. We still need to pass message new job job is box new. This needs to be box new closure. Okay, so we should still do that. Unnecessary parentheses around function argument. Oh, I accidentally added one more. Damn, I'm not needed today. You're always needed, Stacking. Always love to have you around. All right, mismatch types, expected struct, standard box box, found enum message. So now we need to go back down here where I kind of undid this. So initially, what do we have here? We had the job, receiver, lock, unwrap, rec v, that unwrap. So I think receiver, so receiver is this box that we got essentially. We need to take it out so that way we could then check to see what it is. So let job equals receiver.lock unwrap.rec v.unlock. We're going to put this above here. Match job. Print line worker ID got job executing. So that should only go if we get a new job. So match job, new job, job callbox. Okay. Otherwise we get this. Message new job. Mismatch types. Expected struct standard box box found enum message. Oh, so we have the box now. We have to get it out. Oh, right, because callbox is dealing with that. So we need to dereference job to get out what it is. Expected trait fn box found enum message. Note expected type fn box plus standard marker send found type message. Wait, that's different error than I got here, right? Yeah, definitely. So I'm guessing that's going to be something like this, but I think I need a little bit more from this. Okay, so we're sending the new job in worker. So we're taking the exact same thing. Ooh, look at this. Okay, so receiver arc mutex MPSC receiver message. So this needs to be, we're taking in the message instead. We're still going to return the worker, right? Yeah. So creating a new worker, we're passing in the ID. We have the thread in there, so that's some thread spawn move. All right, so now where are we at? Message cannot be, oh, I don't think I need to anymore. So job equals receiver lock. Well, so job is, the job equals receiver is this thing. So we're doing this, receiver, lock, unwrap, rec v. This is all to get out of the arc. The arc and the mutex. So we get that out, then we can match on job, which is now type message. We check to see if message is a new job. If it's a new job, we take this job and then we print our line and we call the function on it. Otherwise, it's a terminate and we then just break. So I think that should be it. Let's continue reading. All right. I guess they're calling this a message, which makes a lot more sense to change this variable name here. So job. This makes sense to call that job still. Change you to message. So now we need a match on message. Message new job, but the job here is fine. Job at callbox, and then message terminate break. Okay, so we should be okay there. I don't need you. Oh, that's what that syntax highlighting was. Okay. And everything should be good still. To incorporate the message enum, we need to change job to message in two places: the definition of thread pool and the signature of worker new. The execute method of thread pool needs to send jobs wrapped in a message new job variant. Then, in worker new, where a message is received from the channel, the job will be processed if the new job variant is received, and the thread will break out of the loop if the terminate variant is received. With these changes, the code will compile and continue to function in the same way as it did after listing 2021. But we'll get a warning because we aren't creating any messages of the terminate variety. Let's fix this warning by changing our drop implementation to look like listing 2025. So the code will compile and continue to function. We'll get a warning because we aren't creating any of the messages of the terminate variety. Oh, right, because we're never actually, like, terminate could never be used. I want to actually see that error. Because I didn't, is this showing me errors? Job. Expected struct standard boxed box found in a message. Oh, it's not box new closure here. It's box new outside of it. Got it. Box new. Like that. That should make it happier. Expected struct standard boxed box. Found type parameter. Expected type standard box. Function box per standard marker. Found type F. Well, isn't that right? Type F. The treat bound message standard FN once is not satisfied. So wait a second. The closure should be have FN once on it. So why are you upset? Are you really upset, or are you lying to me? No, you're not lying to me. Expected struct centered box found in a message or sender. So librs line 43. So thread pull sender, implement thread pull, you see sender and then a job. Okay, what did I do wrong? So it's mismatch types. Oh, this one's mismatch types too. Expected struct centered boxed box. Found type parameter. Was I correct before? Did I just mess it up by this is send message not job? Where was I? Well, oh, like not job at all. I should just send a message right here. Like basically message new job closure. Expected struct centered box. So I'm guessing like I need to send a message and I just put in the box new here. So I was correct initially. Worker should send message, not the job. All right, got that. Expected structure, standard box found enum message. Note expected type, standard box. Okay, let's actually get the real compiler error. Okay, so in sender, found enum message. The job should still be type F, since we need to define the generic for type F. Yeah, well, we're taking a closure of F, type F, where fn wants send and static. So this is being thrown into, well, I guess if I do this, or if I have job equals box new closure, then message new job, and then this is just the job here. The problem is it's not expecting me to send message down. So it's saying this should be compiling, but it's not for me. So I did something wrong. In thread pull, sender is MPSC sender message. Right, this needs to be a message here. So that way it expects that it comes down as a message. I think that's all I needed to do, and I didn't look at the first error. Like I didn't look at the actual thing that we're supposed to do. Variant is never constructed. Terminate. All right, perfect. Wait, where's the error that it says? Oh, we'll get a warning because we aren't creating any messages of terminate. So we're continuing here. We're now iterating over the workers twice. Once the send terminate mess. Oh wait, we're not. So this is what we're supposed to be changing here. So implement drop for a thread pool. That's where we're going to be next. So implement drop for thread pool right in here. Okay, so in function drop, we take in our mutable reference to self, sending terminate message to all workers. For, and we don't really care about this, the mutable self reference to workers, self.sender.send message terminate dot unwrap. Okay, so we need to go through iterate through all the workers, and then we're going to say self.sender. Okay, interesting. Internet crept on me. It's getting near noon. I have only 19 drop frames total this entire time, so I don't think it's on my end. 0.0% of the stream has dropped. Oh, it was yours? Is like your internet go really bad at noontime? Print line shutting down all workers, 4 workers. Okay, so then it's shut down. So the first thing we do, interesting. This is interesting. We don't care about the index of our for loop here. So we're gonna for in mutable self workers self sender send. That allows us to just send an alt to everybody. So let's implement this then. Did we find out the problem in the job? We did. So the problem was I was like sort of going back and forth trying to figure out like where I was supposed to put this this job thing. So in the end, I brought it back to this: let job equals box new closure, and we're gonna self that sender send message new job job. And I was complaining, you're supposed to be sending a box. Why aren't you sending a box? And so I eventually remembered and came back up here to the thread pool, or I was kept on saying sender. Like I'm not sending the sender thing right. So I went up to sender MPSE sender message instead of job or box, and that fixed it. So now we're on to implementing drop for thread pool. So we have for worker in here. So before we go through like the workers part, we're gonna first say, okay, we're gonna send the terminate message. So print line sending terminate message to all threads. We're not really caring about this. Care about, yep, that's fine. And then the next thing we want to loop through, but interesting enough, we don't want to care about this ID. So we're gonna say for, we don't care about it, in mutable reference to self dot workers, right? Yeah. Okay, so then in here we want to actually send the message, which is self.sender.send message terminate enum. Okay, so self.sender.send the message terminate, and then we have to unwrap that. No variant named terminate found for type message. What did I call it? Terminate with a capital T. That would have been nice to autocomplete. All right. So, is that all? And then we shut down all the workers, and it should be the exact same thing. We're now iterating over the workers twice, once to send one terminate message for each worker, and once to call join on each worker's thread. If we tried to send a message and join immediately in the same loop, we couldn't guarantee that the worker in a current iteration would be the one to get the message from the channel. To better understand why we need 2 separate loops, imagine a scenario with 2 workers. If we used a single loop to iterate through each worker, on the first iteration, a terminate message would be sent down the channel and a join on the first worker's thread. If that first worker was busy processing a request at that moment, the second worker would pick up the terminate message from the channel and shut down. We would be left waiting on the first worker to shut down, but it never would because the second thread picked up the terminate message. Deadlock. To prevent this scenario, we first put all of our terminate messages on the channel in one loop. Then we join on all the threads in another loop. Each worker will stop receiving the request on the channel once it gets a terminate message, so we can be sure that if we send the same number of terminate messages as there are workers, each worker will receive a terminate message before join is called on this thread. So we're basically just like blindly chucking terminate messages out and like just hoping. I mean, we're doing it in the same number of threads, so that should work. To see this code in action, let's modify main to accept only 2 requests before gracefully shutting down the server, as shown in listing 2026. So in here, listener equals this. Our thread pool is 4 for stream and listener incoming take 2. So that's interesting. Main. So listener incoming. And then we just want to say we're only willing to take 2 before shutting down. Let stream equals stream unwrap. We've got that. Pull execute handle connection stream. Okay, we've got that. And then print line shutting down. So immediately after this for loop, now we can just do a print line. Okay, so we'll save that. You won't want a real-world server to shut down after serving only 2 requests. This code just demonstrates that the graceful shutdown and cleanup is in working order. The take method is defined in the iterator trait and limits the iteration to the first 2 items at most. The thread pool will go out of scope at the end of main, and the drop implementation will run. Start your server with cargo run and make 3 requests. The 3rd request should error. In your terminal, you should see output similar to this. So let's go ahead and try. So first of all, we need to let's restart the server. Okay, we're running. No warnings or errors or anything else. That's perfect. So we have our sleep, and we have this, and we're gonna do 1 more of these. All right, so we'll do sleep first. Bam. Hit that. This should error, but I noticed that it's waiting for a little bit of time. If we come and take a look at this, we immediately got worker got ID job executing. Shutting down came right after that. Sending terminate message to all threads. Halting thread 0. Worker ID 2 got a job executing. Request, and then halting thread 1, 2, and 3. Interesting, we never got a halting thread 4. And these worked, and this one got the error. Perfect. You might see a different ordering of workers and messages printed. We can see how this code works from the messages workers 0 and 3 got the first 2 requests. And then on the 3rd request, the server stopped accepting connections. When the thread pool goes out of scope at the end of main, its drop implementation kicks in, and the pool tells all workers to terminate. The workers each print a message when they see the terminate message, and then the thread pool calls join to shut down each worker's thread. Notice one interesting aspect of this particular execution. The thread pool sent the terminate messages down the channel, and before any worker received the messages, we tried to join worker 0. Worker 0 had not yet received the terminate message, so the main thread blocked, waiting for worker 0 to finish. In the meantime, each of the workers received the termination messages. When worker 0 finished, the main thread waited for the rest of the workers to finish. At that point, they had all received the termination message and were able to shut down. I guess they only had 3 workers because it's exclusive instead of inclusive in that for loop to create the because we're only going for like 1 to 3 instead of 1 to 4. Congrats, we've now completed our project and have a basic web server that uses a thread pool to respond asynchronously. We're able to perform a graceful shutdown of the server, which cleans up all the threads in the pool. Here's the full code for reference. So, well, it's the same code we have, so we can skip that. We could do more here. If you want to continue enhancing this project, here are some ideas. Add more documentation to thread pool and its public methods. Add tests of the library's functionality. Change calls to unwrap to more robust error handling. Use thread pool to perform some task other than serving web requests. Find a thread pool crate on HTTP crates.io and implement a similar web server using a crate instead. Then compare its API and robustness to the thread pool we implemented. Well, robustness on any crate that's not this one will probably be extremely high. And then we have the summary. Well done, you've made it to the end of the book. We want to thank you for joining us on this tour of Rust. You're now ready to implement your own Rust projects and help with other people's projects. Keep in mind that there is a welcoming community of other Rustaceans who would love to help you with any challenges you encounter on your Rust journey. All right, so that is Rust. So let's go ahead and send all of this code up. All right, so this is like finished the web server project. And we can also go ahead and update that README and basically say that we're done. So currently at, this can be changed to just finished the book. So we're no longer currently at any place now. So let's go ahead, update this here. Finished the book. And send that up to GitHub. Okay, so there's a couple things that I want to do. First, there was one question of whether or not this will work in a Windows system right away on its own, or do we have to do anything special for that? So one problem, so I have my Windows computer over here, and it's what's like serving things out. I don't actually have Rust installed on this computer, so I'll need to get that. I'll need to install that, which I don't think should be a problem because I can use Rust Up or whatever system they have. And then on top of that, we'll be getting the files over there, which should just be able to be done with Git, and then executing it and trying it out. So to begin with, let's find out what we want to do here for that. So let's go to rustlang.org. Install. Oh, I think this is like this is seeing what I've got. Let's try. What browsers do I have on here? I have Firefox. Okay, it's gonna be a little bit awkward, but I'm gonna switch over to the Windows Dev, transition that, so you should just see a whole bunch of, make sure I'm seeing that on this other computer properly. Yep, so you're just seeing OBS. I can minimize OBS now. And let's go to rustlang.org. Go to install. Okay. To install Rust, download and run rustupinit.exe. Okay. That install, that download. Here we go. Ooh, okay, so install the C++ build tools before proceeding. Oh, how I don't miss Windows. I don't miss Windows for development either. Okay, so Rust requires the Microsoft C++ build tools for Visual Studio 2013 or later, but they don't seem to be installed. The easiest way to acquire the build tools is by installing Microsoft Visual. Oh my gosh, okay. You know, hold on. So I have an alternate idea than this. Let's go back to Linux Dev. Okay. I wonder, can I compile and target Windows? So where is that? So documentation, compiler, cargo guide. So I want to cargo build for production. So cargo build for production. So build cache. Hey, there's nothing here about building for production. Cargo reference. Or is it not? Okay, let's try this then. Rust compile for Windows on Linux. It might be under config. Cross compile. That's Stack Overflow. This might be. This is on Rustlang's own forums. Cross compiling from Linux to Windows. I need some help. I have Ubuntu, but not quite this old. Let's see. What's the command they've done? Cargo build -- target. Okay, so is that the command that I would want to do? Let's go back to Rust's website and go take a look at that. Use Rust. Oh, you know what? Standard library use Rust by example might have it also. Cargo book. Okay, let's try one of these. Okay, so Rust by example. Okay, standard miscellaneous. Do we have anything? No. Okay, so nothing in there. Okay, cargo book. You said it was under config, maybe. Configuration? No, not that one. Environment variables, build scripts, publishing. Interesting. Okay, so I wonder if there's like a man page for it. Man cargo. No manual entry for that. Cargo -h. So let's just see what they say. All right, so version list, explain. Rose quiet, color frozen locked. Okay, none of that. Build, compile. Okay, so I can do cargo help command. So cargo help build. Okay, so in here we have package to build. So we want to do everything like the current package we're in. All targets. Build our targets. Live and bin targets by default. Okay, release. Features. Target triple. Build for the target triple. If the package argument is given, the spec, all packages, okay, built. Compilation can be configured via the use of profiles, which are configured in manifest. The default profile for this command is dev, but passing the release flag, we'll use the release profile instead. So I want target, but I don't know what possible target. So maybe we can Google for that. So is there a target in here? Target. For the following sections, triple refers to any valid target literal string triple, and it will apply whenever that target triple is being compiled to. Refers to Rust-like syntax for triple compilation. It's not really telling us like what triple options we have. So let's try Rust cargo target triple. How to cross compile. I want Forge Rustling platform support. That might be good. Okay, so tier 1 platforms can be thought of as guaranteed to work. Specifically, they will each satisfy the following requirements. All right, so we need 64-bit. Okay, so Windows 7 Plus. So it's going to be one of these two. I don't know which one to do, so I'm just going to choose PC Windows GNU. I'm going to choose this first one. So is this this run? 1, 2, 3. That's the triple. Okay, so let's try this. Cargo build -- target, and then that. Okay, and it doesn't say it's equals. It says target triple. So if I hit that, could not find cargo toml. Oh, I'm in the wrong one. So chapter 20 / that. All right, so let's try this again. Can't find crate for standard. Note the x86 64 PC Windows GUI target may not be installed. Oh, is that a crate I need to install? I kind of wish that this was included in the... Oh, wait, you know what? Maybe it is included in the book. I was going to say, I wish it was included in the book. Maybe it's in the appendix. So, cargo book. Oh, wait, not cargo book. Second edition. You need to do a rest up target add. Oh, really? I want to see if in the appendix here. Keywords, different macro translations, newest features. Oh, no. So this doesn't have it either. This is impossible to find, by the way. You need to go through like 20 Google searches. Holy. Okay. You need to do a rest up target add. So rest up target add, and then is it this one? So I like add that. Downloading component Rust standard for okay. All right, so this we are definitely going to be adding to our wiki. So we need to go find that. This needs to be sent to the RISC team address. So this needs to be put into the book. Like that's really what it needs to be put into. All right, so we have code and crates. Let's in here put I kind of like the idea of making this alphabetical. Then we'll put cargo, and so cross filing. Okay, so that should create cross-compiling. There, save this page here and say, okay, steps to cross-compile from Linux. Okay, so the first step is going to be, what was this command we just did? Rest up target. Okay, compile from Linux to Windows. There, rest up target add. I should put command things around it. Okay, so perfect. That. Once we have this, now can we build? So cargo build for this. Okay, linker GCC not found. I think that's because I don't have GCC. So we should be able to do sudo apt update. Go ahead and update apt, and then we'll then download and compile GCC. We'll see how long this ends up taking. Sudo apt install GCC. Okay, we're going to get GCC 7. Oh, we can remove these. We can do that later. Okay. All right, doesn't look like, okay, didn't take too long. So now do we have GCC? We do. Okay, so now sudo apt install, no. This one. Okay, so no is the answer. This is pretty crazy. Aborting due to previous error, could not compile basic web server. To learn more, run the command again with -- verbose. Okay, so let's try it again with -- verbose. Caused by process didn't exit successfully. Rust C -- crate name remains for this. So compiling, running. Linking with GCC failed, exit code 1. This is just like too much to actually pay attention to. Note, user bin LD unrecognized option, enable long section names. User bin LD used the -- help option for usage information. Collect to error, LD returned 1 exit status. So it used an illegal option with GCC. Enable long section names. Let's Google this. I don't want you to go to a file. Okay, this is taking significantly longer than I was expected Google to take. What did I do wrong? Okay, let's try this. I'll just replace it with GCC. Can't? Okay, so this is from Rust Lang issues, so that might be good. Oh, it's still open. Cross-compile from Linux to Windows, i686. Environment, Ubuntu 16, IF17. They're using Rust 1.8 and nightly. I'm not doing that. He just created a hello RS. We ran this. Unrecognized option, enable long section names. That's the same one I'm getting. Same issue with Ubuntu 14. Okay, Thanks to the ports, like with this one, you want to pass GCC instead of ID or LD, but unfortunately i686 probably won't work because the threading model of the compiler at Ubuntu pthreads where we target the Windows threading model and alternate mini GW toolchain. Okay. Tried else, but it didn't work. These symbols are from the dwarf unwinder, which we use in Windows. Okay. I got the same problem, but I resolved it now. It seems Rust lib i686 PC Windows GNU lib from multi-rust is not the good one. I'm going to assume it's because of the use of threads that caused this error. That's what it's sounding like. That's because they're using pthreads for Linux, but that doesn't exist for Windows. If we try to compile just a basic hello, it should work. If I download the native Windows package and install in Windows, you get the correct one there. So basically, if you install both the Rust standard and Rust mingw package, then cross compilation should work out of the box. They closed a bunch of these. You're experiencing the same problem. As a workaround, you can create cargo config with contents like this. It worked on my Linux host. Directory.cargo can be located near cargo.toml file. So error cannot exec the linker. If you're on Linux and trying to cross-compile to Windows, you need to install the appropriate mini GW toolchain. Oh, interesting. Apt install mini GW W64. Wow, this is not good. Okay, so let's go ahead and try this. If this is what we need to do to put this into a cargo config, so in a cargo folder config file. So in chapter 20, close all these down. Okay, so in chapter 20, we have a basic web server. We need a dot new folder, and it's called .cargo. Oh, what happened to it? .cargo. So inside of cargo, we need a new file. Inside of cargo, we need a new file named config. Here we throw this in. So target this. Okay. Now what they're suggesting is that we're going to get this error next. Let's go ahead and try it and see if we can recreate that problem. So target build. Okay, linker not found. So next, they're suggesting that we install using apt. So just using a normal like Linux toolchain here. So sudo apt search. I want to see if we can find this first. Okay. There is a bunch of these. Here it is. development environment targeting 32 and 64-bit Windows. Okay, so that may be it. So sudo apt install that. Let's go ahead and do that one. Feels like it's a longer install than the GCC itself. Oh man, okay. This is why I need to create some like kind of waiting for like a fun little thing. But I'm hoping I could actually use a server, like a REST server, and then I can have that running over on the Windows streaming box. It's almost like Windows has 20 years of crud you need to bring along. Yeah. It's I guess it would also be if I set up the subsystem properly, then it might be easier too. But I want it to work natively on Windows. Okay, so we've got that. Let's now try to cargo build for this. Finished. It finished. No errors. All right, where did it go? Basic web server. Target. Where is it? Like where did we end up putting it? So here's our source. We don't care about that. In target, we don't care about the DARP. Here's the x86 64 PC Windows GNU. There's the debug section and nothing else. Well, that's not helpful. In debug, we have fingerprint. You looked right at main.exe. Oh, main.exe right here. It's in debug. Okay, I wasn't expecting to be in debug, I guess. Okay, so we have. Oh, you know what? Because we didn't do it for production. Let's do this for production too. So. What was that? It's cargo-h. Cargo help build. You could also use a Linux command to inspect the file to see the target system, but I can't remember the command. File, I believe. What I really want to do is not target. I want to make sure we get release. Oh, right here. Compilation can be configured via the use of profiles, which are configured in manifest. The default profile for this command is dev, but passing the -- release flag will use the release profile instead. So -- release. Build artifacts in release mode with optimizations. So that's your, yeah. So -- release. Okay. This should take a little bit longer to compile because it's got to go like do the multiple rounds. All right, so now a released optimized target in 4.3 seconds. That's not too bad. It should now be in debug release. We have main.exe. Okay, so how do I want to get this over here? Let's try. I could put this up onto GitHub, then go find this computer and download it and see if it just works. So we added a config here, and plain, yeah, rsync of Windows. I'm not gonna go there. Plain with, I mean, it's literally right next to this computer, but I'm gonna have thumb drives upstairs. I could go like grab a thumb drive and use it. That actually might not be the worst of ideas, except for the fact that I'm using every single USB slot. So I'd have to like remove something like, I don't want to do that. Okay, so playing with, I'm just gonna put it up to GitHub. GitHub is fine. GitHub is gonna be great. I'm not gonna send it an email. That's bad too. Okay, so playing with building for Windows. Okay, so we're doing that. We're gonna send that on up here, and so over here, on this side, so let's switch over to Windows again. I am now going to be able to go to github.com/BrooksPatton. Target is in your .getIgnore by, oh, is it? That's kind of sad. It is, isn't it? That didn't send up. Let's go ahead and go find Learning Rust. Target's definitely not in here, is it? Yeah. Okay. Oops. So how do I want? I can maybe do. I can maybe just do target release is allowed. Maybe that's what I'll do. Is say target release is allowed. So can I add specifically without removing it? Let's try this. So I want to go to my .getIgnore. I just want, so target, I want to add release. I don't want, okay, so debug release debug. Okay, let's try that. Well, okay, so that gets release, but I want to ignore all these too. So debug target slash. So we want doc release is fine, RLS, and I think that's fine. Let's try this. So we save that. All right, so now we're bringing in release, and I guess that's fine. The lock file. You know what I could do? I could just, now that I have this set up, I can come into target and I could delete it. Delete the target, and then I can recompile. come back up to here. So we have target back. It has, so we got release no matter what. We're ignoring all these things. We have a cargo lock, which I don't think we really need. So we can maybe remove that as well. Get ignore. So target this dot cargo dash lock. Move that. This one is fine. Okay, so x86 64 PC Windows GNU. I want this one. I want the release in here. I don't want a fingerprint. Fingerprint. Or depths. Do I need any of these? I don't know if I need any of these. Probably not. But maybe I do. I just want this main.exe. So I just copy C. Oh, I didn't want to copy that yet. I wanted to copy these first. So I'm going to have 1, 2, 3 more of them. Copy you. Oh, you didn't copy exactly the way I thought you would. Okay, so rename, copy. Name, copy, paste. And then this one is going to be just main.d. Okay, so that should ignore all those. So, okay, now we're going to here, rusty info.json. What are you? Rust fingerprint. Oh, I don't need you. So where you're also inside of this entire general. The stream died. Oh no, it died. Now I'm getting tons of drop frames. 0.5%, 847. It's 1038 here. It's not too bad. Looks like the stream went red for a little bit and it might be back online. It might not. Can you hear me? Am I back? It's like a lot of dropped frames, but it seems stable again now. Then we have main D, and then finally we have this one. Give me dot rust c info.json. Okay, don't care about that. All right, coming into here. Add these in. So adding in the compiled release. And we'll send that on up. Okay, perfect. So back over to here. Oh no, okay. I think I just did that entire time with people looking at the OBS window, which is not what I wanted to do. I forgot to send you back to the code where actually I was doing the cool work. Okay, so if I hit refresh on here, here is our target. Here is main.exe. So I should be able to click on this and download. Save file. Yeah, I'm sorry. I made you watch Windows. Boring, boring Windows. Okay, so main.exe. So let's go to this folder. So if it's expecting the following files. The 404.html, the cargo, the index.html, and sleep.html. So I want to also make sure to get those too. In fact, you know what? Learning Rust, can I just clone or download? Download zip. Save. Learning Rust. Let's now extract all to here. All right, so now it should be more interesting on Windows though. Okay, so Learning Rust Master, Chapter 20, Basic Web Server. We want to take our target and I want to copy, like move this back to the basic web server. So now we have our main.exe, we have our sleep index and 404 HTML. So if I execute this, Windows protected my PC. Windows Defender Smart Screen prevented an unrecognized app from starting. Running this app might put your PC at risk. I suppose it might. Run anyways. Okay. There is no output here, which I suppose is fine. Actually, double click on it opened up this, or Windows doesn't. Oh, actually, you know what? I want to put this on the right and put basic web server. Okay, so now I want to come back to here, put this on the left, and let's go to localhost :3000. Hello from Rust. And what happened to my command? Did it just immediately die? Yeah, my server's down now. Okay, so that wasn't cool. Let's actually try running this from the command line. So how do I? Oh, it's like PowerShell, right? Okay, so I'm in this folder. I need to go into note downloads / Learning Rust Master, Learning Rust Master, chapter 20. Basic web server. Or is it dir? Oh, ls and dir does the same thing. Okay, so now I want to run main.exe. Okay, so it shut down right away. Request. So it ran one time. So worker ID 0 got a job executing. Worker ID 3 got a job executing. Oh, you know what? We, okay. This server would be a lot better if we didn't have that silly only do one thing. So back to Linux to fix this. So in, not release, in our basic web server, here it is, source, main RS, we don't want this silly take two anymore. That's a silly thing. We want all of them to run forever. So we save this. We have to recompile too. So I guess first let's test it. So Rust, no, cargo run. I completely forgot that we were not allowing this. Okay, so if we hit U, hello from Rust. If we hit U like a bunch of times, it still works. Perfect. Everything is working here the way we want it to. So let's quit out of here, and we're going to now cargo build or release. And then we're going to RS. Okay, so now we update this and we'll say, so server now takes more than 2 requests before shutting down. Push this up and then back to Windows. This is a great, lovely workflow, isn't it? Okay, so let's come back to downloads and let's just delete this learning rest. This is unhelpful. We also want to close. Can I? Oh my gosh. Okay, CD. Okay, downloads right there. We'll remove you. I can just drag you to the trash. Back to our browser. We want to then, so I think what happened was the browser detected the server was running again and then try to run it again. Don't forget the folder. Did I? Oh, learning Rust master. Want to get rid of you. In fact, what do I really care about here? Nothing. You're all going away. Okay. Back to here. Let's go ahead and clone or download again. Download zip. Save file. So in here, we're going to extract all. Extract. So in here, we should now, I have to like awkwardly put my hands around the microphone, which is super fun to type with. Okay, I might be in front of it. My picture. Let's go over on here so I can actually see how it looks. Okay, yeah. Over here is better. And can I make this any bigger? Okay, no, I don't know how to make it any bigger. That was horrible sound. Okay, so learning Rust master. Learning Rust master. Chapter 20. Basic web server. Okay. I also have to do that entire move thing. So in here, we go in chapter 20, basic web server, target this release, main. I'm going to put you into basic web server again. Okay. And then we're going to run main.exe. Okay. Server is running. Back over to here. We hit refresh. We executed a web server. Okay, so we have hello from Rust. Look at this. So worker 1 got a job executing request absolutely nothing. So is Windows hitting this web server? Like, is it scanning this port or doing something on it? It might be. Now, if I come over here and we go to localhost 3000/sleep, got a job executing, it's waiting, and we hit. It's happening just fast, and this happened. So the threading is working correctly now too. All right, so we've got it. It's Windows strings causing the problem. Okay, interesting. So it's like hitting weird things. They use some kind of fucked up UFC 16. Interesting. UTF 16. Yeah, I don't know anything about like actually developing core like Windows applications. But the basic thing is, the thing that we really care about is the fact that we now have Windows, a server that we wrote over here on this computer in front of me, and it's a multi-threaded web server. It's now running natively on our on this Windows 10 machine with threading that's actually working properly. And it's something is hitting the server every once in a while. It might be this like UTC 16 or UTF 16 weirdness, but that doesn't seem to be affecting it the way we really care about, because we actually have a server. We have a web server on Windows. So the cool thing about this, like what I'm going to be able to do, and I have to figure out how I want to design it. If I take, I'm not sure how I'm going to want to make this look. If I come over here to OBS, let's take it off studio mode so we can see the entire thing. Woo, craziness. Let's add in a browser source. Browser. New browser. Can I make this full screen? No, I can't make this full screen. Okay, so the idea is that I can go to localhost :3000 and then just hit this whatever I want. Custom CSS, I can maybe just do color is white. I don't want to shut down the stores, refresh the browser. Okay, so hit OK. And I don't know if you can see, but in the top left here is this hello from Rust. So if I now minimize this down, move these windows out of the way, we should have a hello from Rust up here. Now I can't see that on a Windows machine. It's been overlaid by OBS. So I need to wait for my, yep, there it is. So the cool thing is, what I'm going to be able to do is have a server running, which I'm going to have in Rust, and then I'm going to create a few different websites that I can then, web pages that I can load up, like a waiting for, like, so at the beginning of the stream, waiting for, you know, the stream to start. And it could be like the Rust icon that is then, it's then like, you know, spinning or something around. And then anything else that I want to do, like taking break, thanks for watching, anything else really. And I'm all going to have that powered by Rust here. But I'm gonna need to sort of like plan that out, design it, and then probably on the stream, we'll make that. And it'll be good. The question is, do I want to use this web server, or do I want to use, like, you know, an actual web server that one would use in the real life? This works just fine, because all I would need was just to add in routes for grabbing the CSS and the JavaScript files, if I need those. But other than that, I think it's like a fairly basic workable web server. Anyways, so I've been talking for about 2 hours now. I think what I'm gonna do is go off and take a break. I may or may not stream. I'm gonna be streaming probably randomly throughout the next 2 weeks. And then probably not streaming in the morning anymore, because I don't know exactly what my schedule is gonna be. But until then, we'll just enjoy weird random streams. I still plan on streaming the early morning streams. I just have to, like, you know, get myself to bed early enough to wake up early enough. So plan for tomorrow morning at 7 a.m. I don't exactly know what we're going to build, but I'll figure that out today, and then we'll have something for tomorrow. I should head back to Linux, because this is not the funnest. Studio mode. Linux dev transition. That's better. Now we can look at a more Linux machine instead. Anyways, with that, thank you everybody for you know, going through the Rust book with me. We are done with that, and now it's going to be on to projects and other fun little things. Another thing that I've been some ex coworkers of mine have been trying to get me to get into playing some games online with them. Specifically, they want me to play StarCraft while on their lunch break. So I'll probably be doing that today, not streaming today, but in the future I might stream some of those. I am not good, so in case that you want to see some top level play, I'm very sorry. I am not the person for that. But I'll be announcing more of those things on Twitter. So if you want more information about like what's happening with my stream, please follow me on Twitter. I have links below. I also have all the code that you've seen is up on GitHub and available for you to play with. You can now download this server onto Windows and play with that there as well, and everything else. So with that, I am going to I'm going to go figure out what to do with the rest of my day, plan things out, and then I'll see you on, if not later today, then tomorrow morning.